So welcome to this session. Today we unpack one of the most fundamental ideas in acoustics, or we'll be specifically discussing about the sound. So we'll try to talk about the fundamental note, is the overtones. So we try to see what a fundamental note actually is and how overtones and the harmonics build on top of it, just to give every instrument its unique character. So by the end, you'll be able to keep these terms, harmonics, partial and the overtones clearly or just straight, so that you can be able to understand them. So that's what we'll be covering up. How a single vibrating object just produces one lowest pitch in the whole spectrum of the frequencies that are laid above it. So let's dive into it. Now, here's the whole story in one, just one side. Just when an object vibrates, it doesn't move at just one frequency. So there's a single lowest frequency, that is the fundamental. The fundamental, this is just the single lowest resonant frequency, the pitch where we name. Now, plus an infinite series of the higher frequencies. Those higher ones are what we call the overtones. So every frequency above the fundamental are what we call the overtones laid together. Uh, uh, the special subset that is set just at whole number multiples of the fundamentals are what we call the harmonics. So the harmonics, these ones are just the overtones at the whole number multiples of the fundamental. So these are just the three of the what one vibration can have, these various frequencies. Moving on. So we'll try to discuss them one by one, starting with the first one, the fundamental note. This is just the lowest resonant frequency of a vibrating object, and it is the pitch that our ear identifies as the note. So most vibrating objects, they have more than one resonant frequency, and the ones used in musical instruments typically vibrate at the harmonics of that fundamental. So take an example, a flat string, any and also an open cylindrical air column, a conical air column, all vibrate all at the harmonics of the fundamental. So that's about the fundamental note. Now, there's lowest resonant frequency, whereby the lowest, this is just the slowest mode at which the object naturally vibrates. Then the most objects, they have these many modes, as we said, for example, the plugged string and the open cylindrical air column and the conical air column. So most objects, they have these many modes. The fundamental is just simply the first and the lowest of them. Then instruments, they favor the harmonics, as we said. Now strings and the air columns vibrate the whole number multiples of it. So that's about the fundamental note. Moving on. The harmonic series on a string. So this is the harmonic series. The first harmonic is just the fundamental itself. This one, as you can see, one half wavelength across the string, while the second harmonic, it just vibrates at twice the frequency. The third harmonic, uh, uh, and so on. So notice the two counting systems. The second harmonic is just the first overtone. That offset is just the single most common source of confusion, and this what the next slide clarifies. So we'll see the next slide that clarifies this thing or this concept. So as you can see, the harmonic series on a string. So each mode fits just a whole number of half wavelength between the fixed ends, as we've seen, the first harmonic, the second harmonic, the third harmonic, and the fourth harmonic. So here we have the overtone. So the overtones, a overtone by definition is just is any frequency higher than the fundamental frequency of a sound. So using the model of the Fourier analysis, the fundamental and the overtones together are just called the partials, and the harmonics, or just the more precise harmonic partials, are partially whose frequencies are just integer multiples of the fundamental. So as we said, the definition, the overtones just is any frequency higher than the fundamental frequency of a sound. Uh, eh, eh, from there, it's above the fundamental. Any partial higher than the this fundamental qualifies as an overtone, and partials just goes to fundamental plus overtone. So in the, as we said in the Fourier's analysis, all the components they are together. So harmonic partials, they are just the overtones whose frequencies are just the integer multiples of the fundamental, while shape the timbre, they are just their relative uh, their relative strength given an instrument, uh, uh, given to a behavior of a certain musical instrument. So the overlapping terms are just used when discussing the acoustic behavior of the musical instruments, which we have seen through this out talking about the overtones. Moving on. Uh, So what the counting doesn't line up. So it is just important to note that the term overtones, yes, it does not include the fundamental frequency. The first overtone is just therefore already the second harmonic and the second partial. So the term overtone is just should never be mixed with the other terms because the counting is unequal. So you can read through this table. Now across each row and column, you can see the mismatch clearly. So the partial and the harmonics start counting at the fundamentals. As you have seen, the frequencies, then there's partial, the harmonic, then the overtone. So the overtone should never be mixed with the other terms because the counting is just unequal. So therefore, when you read across this table, you can see the mismatch clearly, and the partials and the harmonics, they just start counting at the fundamentals. The fundamentals are right here, and the overtones start counting just above it. So that's the table that just help to understand the key terms related to the overtones, including the fundamental. So the overtone numbering just lands behind the harmonic. So I hope that's clear enough. So if you take one thing away, take this, just the word harmonic has a precise meaning. The term harmonic has a precise meaning that an integer multiple for a fundamental frequency. So the first overtone is just the second harmonic. So the harmonic and the partial, they count from the fundamental, and the overtones just count from above it. So that's you can remember from this session. So because overtones, they just start counting above the fundamental, the first overtones equals just the second harmonic, anchor everything else just to the given relationship as we have seen from the other slide. So to summarize everything, the fundamentals are just the lowest resonant frequency. So the spectrum in just one breath as the fundamentals are just the lowest resonant frequency. The note we hear. Then the overtones are just every frequency above the fundamental. Uh, Together, the fundamental and the overtones are the partials, and the harmonics are just the partials at the whole number multiples of the fundamental. And just never to forget the counting mismatch as this the catch, whereby the first overtones is just the second harmonic and the counting differs. So that you have to note it also. So that's all I have for this session of the square, everyone. Thank you for listening. We've discussed about these things, and you've seen them in here in this summary: the fundamentals, the overtones, the partials, the harmonics, and the catch in terms of the counting, how it differs. So that's all I have for this evening, and thank you.